Hello everyone. Today we are going to see dual nature of light and de Broglie hypothesis. First of all, we'll see dual nature of light. Light has dual nature. That is, it is particle as well as wave character. Why this light shows dual nature? Question arises. We know, according to classical physics, light is treated as wave. Why? This is because interference and diffraction of light are produced by superposition of beams of light. Thus, these phenomena are the result of interaction of light with light. From experimental observations on interference, diffraction, reflection, refraction, and polarization and their interpretations, it is concluded that light shows a wave motion. Therefore, these phenomena are completely explained by the wave theory and the electromagnetic theory of radiations. Whereas quantum physics treats the light waves as particle. The phenomena like black body radiation, the photoelectric effect, and the Compton effect are produced by interaction of radiation with matter, and these cannot be explained by the wave theory or the electromagnetic theory of radiation. To explain these phenomena, radiant energy is considered as a stream of small packets of energy. These packets of energy are known as light quanta or photons. So we can say that light has dual nature. It shows particle nature as well as wave nature. So we can say an electromagnetic wave of wavelength lambda and frequency f can be thought of as a stream of particles with energy E and momentum P, and is given by E is equal to hf and P is equal to h by lambda. So, the frequency or wavelength is a concept relevant to a wave, and quantum having the isolated energy hf is the concept of particle. Therefore, we conclude that radiation possesses dual character and it never exhibits both characteristics in any one experiment. Now we'll see the photon momentum. A photon is a massless particle which carries energy. So, we can write the photon energy E is equal to hf. And since we know f is equal to c by lambda, so we can write E is equal to hc by lambda. The momentum of the photon is related to wavelength by the equation P is equal to E by C. We know Now we substitute the value of E as hf. The equation becomes P is equal to hf by C, and in turn it can be written as P is equal to h by lambda. So we can write the energy in electromagnetic waves of wavelength lambda can be thought of as being carried by photon particles, each having a momentum of h by lambda. Now we'll see de Broglie hypothesis. According to de Broglie hypothesis, light sometimes behaves as a particle and sometimes as a wave. Perhaps material particles such as electron also have wave properties. So de Broglie hypothesized that a moving particle has a wave associated with it, and the wavelength of the particle is related to the particle's momentum. So we can write P is equal to m into V, which we have seen earlier. And now we are going to substitute this P is equal to mv in the equation of wavelength. So lambda is equal to h by p, where h is the Planck's constant and p is the momentum. By substituting the value of momentum, we can write the equation for wavelength as lambda is equal to h upon m into v. These waves associated with moving particles were called matter waves, or more commonly called de Broglie waves.